Welcome to the Spruance DD ship brief. Let's begin with our sources. We use just a couple sources on this one, globalsecurity.org. All right, so let's begin with who is Admiral Raymond A. Spruance, the man this class of ship is named after. Often called the Quiet Warrior. It's also the name of his biography, The Quiet Warrior. I recommend you read it if you want to learn more about Mr. Spruance. Admiral Spruance. He was born in 1886, so a long time ago. Served in the Navy for decades, a full career. Probably his biggest accomplishment was commanding Task Force 16 at the Battle of Midway. You know, he was instrumental of making that a victory. You know, he was the best. After that, he was commanded or promoted to Chief of Staff to the Commander-in-Chief of U.S. Pacific Fleet in 1943. He also directed the capture of Iwo Jima and Okinawa. So very successful World War II career. He was the president of Naval War College for a couple years after the war, and he died peacefully at his Pebble Beach condo in 1969. A full life well lived. All right, so how does this begin? Well, as with most of our ship projects, it begins with a fleet study. Well, the Americans do fleet studies too, not just the Russians, and this one was 1967. They determined a couple things from this study: that the number of escort ships in a fleet is determined by ASW requirements. That's not 100% the only determination, but it is a big one, and that's where this ship comes from. This is going to be an ASW platform versus an aircraft platform like an aircraft carrier or even an AAW cruiser like the Ticonderogas will become. This is an ASW platform, and it's going to have long-range sonar, but just point defense or medium-range air defense capability. So it's not there to protect the fleet against, a long-range missile attack. It can protect itself, which is the point defense portion, but it's primarily going to be a long-range submarine hunting platform. It's going to have a couple 5-inch guns that can be used technically for shore bombardment or ship-to-ship action, but the limited range of the 5-inch guns really pales in comparison to, say, the battleships we had at the time with their 16-inch guns. But she still has 2 of them, which is more guns than most Navy ships, American Navy ships, have today. It's going to be built in Linton Ingalls shipyard. They provide the design for the gas turbine engines. This is going to be the first all-electric ship. It's going to be using the gas turbine engines that were also used on the Oliver Hazard Perry class frigates, except this one will use 4 of them instead of 2. This is also the first ship to be built under total package procurement, which was a theory put into practice under the Lyndon B. Johnson administration. It was not successful, but it kind of worked for this project. And the idea was to build one class of ship at one shipyard so that it could, the workforce, as they built the one ship after another, would become more efficient and better at their jobs, and they could maybe bring down the cost of shipbuilding by being better shipbuilders for one type of ship. And so, Linton Ingalls Shipbuilding is going to be the shipyard that builds all these ships, all 31 of them. And the idea was to save money by doing that. It turns out it didn't work. Costs ballooned anyway because you still have many other people involved in building these ships, despite the fact that they're assembled in one place. You still have, all sorts of different companies participating in this, and that drives up costs. So the total package procurement did not work, but it was tried in this project. Okay, a multi-year contract for one shipbuilder for all 31 ships, like I said. And Ingalls Shipyard is in Pensacola, Mississippi, down there on the Gulf Coast. Okay, so like I said, the purpose of the Spruance is to hunt down and destroy submarines in all weather and in all conditions. Her ASW weapons include 2 triple-barrel Mark 32 torpedo launchers that shoot the Mark 46 and later on the Mark 50 anti-submarine torpedo. It also has a hangar for 2 SH-60 helicopters, which are very good at moving around and, dropping sonar buoys and hunting for submarines and transmitting all that data back to the ship, where it can be combined with its hull-mounted sensors to look for submarines. The helicopter is a big force multiplier when it comes to ASW hunting. So the SKS-53 hull-mounted active sonar is on the bow. The SQR-19 tactical towed array comes out the stern. Those are two arrays that the ship will use in conjunction with the helicopters. In 1985, the SQQ-89 sonar system is combining these arrays into a single suite. This data integration is important. Back in the day, in 70s and 60s and before, you had dedicated stacks that did one thing, whether it was your hull array active or your towed array passive, but you could not share data between the stacks. Well, whenever it came in with the SQQ-89 design, which is still in service today under version 15, it combines the data. So you not only can you swap displays between these common consoles, you can also take the data from your towed array and put markers on your hull array indicating the direction of the detection. And you can take sonar buoy data and overlay that as well and get a nice little triangulation picture of where the detection is coming from without doing really much operator intervention in modern day systems. So the SQQ-89, huge capability leap, combining all these sensors into one sensor suite and then sharing that data with fire control and stuff. It's a whole package, and that comes in 1985, a little bit later. All right, so let's talk about Ingalls Shipbuilding in Pascagoula, Mississippi. They've been building ships for more than 80 years, and they have hired they operate with more than 11,000 employees. That's a huge industrial employer for Mississippi, and they built all the Spruance class DDGs there. And there you can see some great pictures, aerial shots of this enormous facility where they just assemble the ships, put them on these floating dry docks, and then take them out and launch them just off the beach there. You have a nice shot on the right there. That's 6 Spruance class destroyers at various points of completion under construction. So there you can see some with, just the bare bone superstructure all the way up to what looks like a completed ship there on the left-hand side. Very good picture. Okay, built between 1975 and 1983. This is the first time they used trapezoidal loading on these floating dry docks. These floating dry docks, or SKEGs, as they're called, is what they would move the ship out onto after it was assembled and they were completing it, finishing it up, and then the SKEG would go out into the water there just off the beach, and they would submerge it and launch the ship. That's kind of like how it's done. These SKEGs, though, had never handled a ship of this weight before, so they had to do a different type of keel block loading called this trapezoidal loading, which is fine, if you balance it right, but they had to reinforce the SKEG just to handle the weight, and the balance was not completely correct on the first Spruance, and this happened. The front half of the dry dock, because the ship that's loaded in the dry dock on the left there is facing away from the camera, basically broke in half, and it flooded out the starboard side and then eventually the port side of this floating dock. Now, this happened when they were trying to launch the ship anyway, so they quickly were able to get in there and balance the load by a combination of blowing air into one side of this SKEG to blow the flooding water out and counter flooding the other side to try and keep the ship on the keel blocks, because if the floating dock had shifted any more over to the starboard side, then the entire ship would be at risk of just falling off the keel blocks and falling over onto its side. So what they did was they continued with the undocking procedure and just quickly got the ship into the water and let the SKEG sink the 75 feet or so down to the bottom of the bay there. And there you can see some pictures of it as it broke apart. The SKEG did not sink quickly, but it did shear pretty fast. The damage was obvious pretty quickly, and they managed to get the ship launched before the whole thing fell apart. And that was the dubious beginning of the first Spruance destroyer. All right, so the Spruance, by the numbers, she has 4 of the LM2500 GE gas turbines. These are the same engines used on the Oliver Hazard Perry, each producing about 20,000 horsepower apiece. She's over 560 feet long, 55 feet wide, and weighs 9,100 tons. She has a max speed of 33 knots and has an endurance of about 8,000 miles if you keep her around 20 knots. You have to keep the speed down a little bit, and you can get 8,000 miles out of her between refuels. She has 2 of the SH-60 helicopters and a crew of 350 men with 30 officers. By today's naval standards, she has a lot of weapons, but whenever the ship was designed and came out, one of the criticisms of her was she didn't have enough weapons. So here's what she had. She had a Mark 143 ASROC launcher on the bow. In this picture here, that's been replaced by the Mark 41 VLS, which came later. There were 4 different variants of the Spruance, and so one of the things that they did during this whole project was to remove the forward-facing ASROC launcher and replace it with the VLS box launcher, or vertical launch system. She had 2 Mark 141 Harpoon quad launchers, one Mark 29 launcher for Sea Sparrow. That's the box launcher or boxy shaped launcher there on the aft part of the ship. She had 2 of her Mark 45 5-inch guns and 2 Mark 15 20 millimeter Sea Whiz guns. So her point defense was good between the Sea Sparrow and the Sea Whiz. She was good to go. You could even take that Mark 45 5-inch gun and shoot it at an incoming missile. Chances of getting a hit are pretty remote, but she has good short range and defensive capabilities. But remember, her primary mission is ASW, and that's where her long range is in that sonar and that helicopter dropping those Mark 46, Mark 50 torpedoes. So they built a total of 31 Spruance class DDGs. There originally were only going to build 30. So how'd they get to 31? That's an interesting story we'll share with you real quick. After they got the funding for 30, the Navy did. The Navy later on, a few years later, went back to Congress and said, hey, Spruance class, really good ship. We find that the helicopters are doing a great job. We want to build more Spruance class, get more helicopters ASW capability out there. Congress, who authorizes funding for projects like this, says, all right, we're going to give you money for 2 more ships. But since you say the helicopters are so effective, we want you to build 2 ships that can carry more helicopters. It's going to be designated DDH, or Destroyer Helicopter Ship. And the Navy says, okay, give us the money, we'll do that. And the Congress authorized the money. They go back down to Mississippi. They start building another Spruance. That's where 31 came in. But do you know what they did? They just built another Spruance. They didn't build a DDH at all. They just built the 31st of class of Spruance. And Congress found out about this and said, hey, we're not giving you any more money. You're not getting the second ship. And that was the short life of the DDH class that was never actually built. The Navy straight up took their money and went and built what the Navy wanted, not what Congress told them to. All right, so here are the 4 variants. There you can see the helicopter pad on the back. There are some helicopter hangars that they winch the helicopters in and out of. They have 2 of them, of course. If the biggest difference really is on the bow, you can see how the ASROC launchers are on the 2 on the left, and then you have the VLS up there in the top right-hand corner. It's just flush with the deck. And then the big one in the bottom right-hand corner of that picture, it looks like it has 2 box launchers. That second box launcher, the long one, that's a Tomahawk box launcher. So there was a short period of time where a few ships, I think it was only 2, had a Tomahawk box launcher for testing purposes next to the ASROC launcher. So you had Tomahawk, ASROC, Tomahawk, going left to right, right to left. And then eventually they just got rid of all the box launchers on the bow and just put in VLS. And they put the ASROC and Tomahawk in the VLS. The boxy launcher there you see on the aft end, that's the Sea Sparrow launcher. And they would eventually remove that too in a variant. Okay, so here's the 4 LM2500 gas turbine engines. You can see there the technician is working on it. It is essentially an aircraft engine modified slightly for marine use. These 4 engines turn 2 shafts, so they have 2 physically connected to each shaft. They produce a total of 80,000 horsepower for both shafts. Top speed of about 32, 33 knots. Maybe 33 going downhill, you know. The startup, this is the big thing that everyone stresses about these engines. The reason why these engines were so great is that it was a big leap going from steam-powered turbines to gas-powered turbines, because the gas-powered turbines, you can get them warmed up and ready to go from a cold, not moving start in about 10 to 12 minutes. And you can get that ship underway, casting off lines, in under 20 minutes. So you can make your Navy, bring them into port for maintenance and whatnot, and still have them be a rapid reaction force to an incoming threat. Also, maintenance on these was pretty easy. And if you had to replace one of the engines, you didn't have to cut a hole in the ship to do it like you do with many other designs. They could literally hoist them out of essentially the smokestack area, take the smokestack area off, and that gives access to the engine here, and they can crane the old one out and crane a new one in without any hole cuts. All right, so let's talk about some of the equipment on the Spruance. First is the SPS-40E 2D radar. 2D. So this is long-range surveillance and detection. It provides target bearing and range. Modern, phased array systems, 3D radars will give you the third information, which is the altitude. But this one gives you bearing and range. So you can see a contact out there at, 80 miles, bearing 340, coming at. It's high performance and reliability. It's also a low-cost radar because it had been around for ages at this point. And it's high resolution for multiple missile track. So whenever contacts start to get close, it does have a high-resolution mode where you can see exactly how far away the missiles are to help guide self-defense ordnance onto it. All right, so the SPS-55 surface search radar has a 50 nautical mile range, has automatic gain control. This basically is just you flip it on and it begins rotating and radiating and you just let it go. It doesn't require a whole lot of operator input other than you just pay attention to the screen. It has sector search capability and reduces clutter with filters. So like if you have fog banks and stuff like that, you can reduce some of that. Also, it has a land mode too. So if you wanted to map land, you could. SPS-64 navigation radar. This is a 65 nautical mile range radar. It is commercial grade. It is the same radar used on many commercial ships, which is great for deception. So if you wanted to roll around in your Spruance with all your radars turned off, but you want to navigate safely, so you turn this radar on, surface search radar, navigation radar, and you look like a commercial ship, right? Because it's the only thing radiating from you. It's a high pulse rate, narrow bandwidth radar. It has a 12-inch CRT display. CRT is cathode ray tube. Very old display, but for the time, it's state-of-the-art. And provides data to the two SPA-25 radar indicators. And those are the displays essentially in the bridge and in the control room where they can just look down at this upward-facing screen and see the 65 nautical mile range around them on the screen there. All right, let's talk about the SKEG 60 and SPQ-9A gunfire control radars. So the SPG-60 provides gun control data. Radars are teamed together, and the SPQ-9 provides surface surveillance and tracking data. So the SPQ-9 is like looking for the target and then tracking the target, and the SPG-60 is taking that data and laying fire on it from the guns. Very reliable. They're still in use today. The SPQ-9A is still in use today. All right, here's the SQS-53 sonar system. It is a bow-mounted, active and passive hull array system. It has extremely large amounts of power. The version today is called the SQS-53 Charlie. It has a greater than 80-mile range. That's kind of a joke that that's even there, but that's the unclassified number. You would be shocked. You would not believe me if I told you the range of the sonar system. It's incredible. And a lot of it has to do with the power it puts out, to be honest with you, but it can also take advantage of propagation paths in the ocean to get insane ranges. You would not believe. This is one of the systems that I'm currently working on as a military contractor. We're working on SQQ-89 version 15, which incorporates SQS-53 Charlie sonar system into the new version. And there's just new things we can do with the technology we have today that are mind-blowing. And so it's a bad day to be on a submarine if you're in the vicinity of one of these things and you're in the right conditions. Anyway, I have a really good video on this on YouTube. If you just Google the SQS-53 Charlie active sonar from November 2018, I go in depth as to how this works. Okay, SQR-19 Tactical Towed Array, or TACTAS, was used. They have different towed arrays now, but the TACTAS, I believe, is still around. It's basically a fat line towed array is what we called it on the submarines. It has very long passive performance. It revolutionized ASW warfare for sure, because now the surface ships had a reliable passive sonar array where they didn't need to give away their own position with active transmissions, and they could still track submarines. Yeah. So this thing was out there being towed hundreds of feet behind them and was able to detect submarines from a pretty good distance. Okay, SLQ-39 electronic warfare system provides early warning and identification of threats, direction finding for incoming missiles, and also has an electronic attack capability. It basically tries to, blind their sensors with electromagnetic transmissions so that essentially the seeker head doesn't see anything on its terminal dive to target. It just hopes that it gets close to whatever it was previously aiming at. Meanwhile, the ship is moving, ideally out of the way of the missile as it comes in. So that is the SLQ-32 electronic warfare system. The details of these systems are very classified. Like there's no public data on how these work, because then if you knew how they work, they could easily be defeated. So there's not a lot of information on these. Let's talk about the Mark 41 vertical launching system. This is the VLS that replaced the ASROC launcher up forward of the control and behind the forward gun mount. It holds a lot of weapons, and it has a number of different advantages in that each weapon is encapsulated in its own canister. So it's never subject to foul weather of any kind. It can be easily maintained from inside the ship, as you see the Chief Petty Officer there walking around inside the ship, around all the different VLS canisters, checking, making sure that they're properly secured and whatnot. And it does support multiple different weapons. You can shoot a Tomahawk out of these. You can even shoot surface-to-air missiles out of these. And but primarily the ASROC was moved to VLS. The anti-submarine rocket was moved here. All right, so this is the RUR-5 box launcher. The RUM-139 is the VLS version of the ASROC. And it basically has a ballistic missile that delivers a Mark 46 or Mark 50 torpedo to a very specific range. And one of the reasons they got rid of the box launcher on front is the box launcher had limited amounts of pivoting and moving and being able to aim, basically. It also had a very narrow window relative to other weapons. Let's say it only dropped the weapon at, say, 6,000 yards. So you would have to position the ship so you're pointing the target, and the target is approximately 6,000 yards away before you could fire. Well, the time it takes to do that, the target could be evading, it could be attacking you, you could be under attack from other vessels. So it was better to put a VLS in and shoot this thing straight up in the air and then let the rockets take it to wherever it needed to go. And that's another reason why they got rid of the box launcher there in the front. But going back to the weapons itself, this weapon was nuclear capable, and these rockets were deployed rather at sea with nuclear warheads on them during the Cold War. And the idea was to just shoot it in the general vicinity of a submarine and let the nuclear warhead do the rest. It had approximately a 20 kiloton warhead, so relatively small, but still, whenever you're in a submarine, it certainly doesn't seem small. Okay, the RGM-84 Harpoon missile. It's an all-weather over-the-horizon anti-ship missile. This missile's been around for ages. It's very reliable, but it's starting to show its age now in the 21st century. Very easy to defeat, whether with ballistic, countermeasures or just simple electronic countermeasures. But back in the day, she was the go-to missile. 60-plus mile range, had GPS guided. Basically, you could fly it to a waypoint and it would make a maneuver. So you don't necessarily fire it right at the target initially. Block 2 has INS and GPS combined. Has a simple target acquisition seeker. And there was a SLAM, or a surface land attack missile variant produced. I don't know if it was ever employed, but it was produced for sure. And there's also now an ER extended range variant that gives it a range of over 150 miles. But the big vulnerability is that subsonic speed. Missiles, even during the Cold War, were supersonic. And now in 2021, we're getting into the hypersonic missile age, which is just beginning. So this weapon is quickly becoming obsolete, but we still have a lot of them, and they're still in use today. That's the RGM-84 Harpoon missile. The RIM, or Rolling Airframe 7 Sea Sparrow surface-to-air missile. This is the naval version of the Air Force's AIM-7. It's a radar-guided semi-active homing. In Mod 6, they made it semi-active homing. Otherwise, it was completely radar-guided, basically following the radar beam from the ship to the target. It has a large warhead, which is nice. So even if it doesn't physically strike the target, if it gets in the vicinity and explodes, the sympathetic explosion will, usually knock the missile or airplane or whatever it is it's shooting out of the air. It does have medium range, which just means it's slightly more than the Sea Whiz. It's really not long range at all, just enough basically to defend the ship. You might be defending a ship that's right next to you if you're really close to it, but this is basically a self-defense weapon. It did have a high failure rate and was pretty expensive for compared to other defensive measures. It was also high maintenance, and for some reason the Navy didn't have a lot of parts on board, so if one failed, you would simply swap it out and take it back to port and have it redone. Also, the launcher itself had a high failure rate. So not a great system, but they kept the system for a long time on board, just part of its self-defense package. Okay, the Tomahawk quad pack launcher modification. So the Tomahawks came along in the 80s, started being tested, and the Spruance was one of the platforms that was testing them. So they put a quad pack, that's a 4-pack, 2/2, on either side of the forward ASRock launcher. And it was used for testing there. You can see a couple photos of them successfully launching the Tomahawk's rocket motor booster. And then it goes into subsonic cruise using a turbine fan engine after this rocket motor burns out. The Mark 15 Phalanx, an absolute icon of American ship design or even NATO ship design. It's a 20 millimeter rotary cannon that shoots a 20 millimeter plastic sabot that the plastic part falls away immediately after launch. And you have a 15 millimeter penetrator warhead, lead slug essentially, inside of that. It has a 900 to 1500 round magazine. It shoots 4,500 rounds per minute, so you can empty that magazine in a hurry. And it has a couple different modes. It can shoot 60 round burst, 100 round burst, or just continuous firing, just fire until the target it's shooting at is gone. There you can see a great picture of them loading that 20 millimeter sabot round. The white tips, if you look closely, are just a protective sabot that helps protect the barrel as you shoot it. And that white plastic falls away the moment it leaves the barrel. And so you have this 15 millimeter slug that's remaining, that's going out to hit the target. All right, Mark 45 5-inch gun. Fully automatic, lightweight gun, still in use today. Very reliable. It's an anti-ship surface bombardment weapon. Can shoot about 13 miles. So if you're going to do surface bombardment, you got to get really close. You better hope your target's on the beach, Even getting within 13 miles of land is sometimes a navigation hazard, much less shooting a target that's going to be a couple miles inland. They did come out with an ERGMS round in 1997. This round is in use today. It has over a 60 nautical mile range. It's fin stabilized, GPS guided. This gun can shoot 20 rounds per minute and has a 500 round magazine per gun. Remember, there's 2 guns, one forward, one aft, each having a 500 round magazine. The Mark 32 Surface Vessel Torpedo Tube, or SVTT, are mounted on all American warships now. One thing that's unique to the Spruance, though, is this one was inside the ship. You can see that they open basically a door, a port, if you will, on the side, and they rotate this thing out to point outside the ship. Whenever it's not in use, they simply rotate it back inside the ship and shut that port. And then you're inside the ship environment, controlled environment, working on the weapons, loading it, maintaining it. This is a much easier way for the crew to maintain these kinds of weapons versus, say, the current Arleigh Burke class that has this weapon topside. So, you can only work on it in certain conditions. Whereas on the Spruance, you could work on this in any weather and at any time of day. It fires the Mark 47, Mark 50 ASW torpedo using a 1,600 pound pressurized air flask. The air flask looks like a little sphere that fits into the back of it, and that sphere comes off. You can recharge it because it's a one-use sphere. Once you've launched all the air out of it, you got to take it off and put more air in it, and the thing just simply plugs in and plugs out. The torpedoes are completely self-homing, so they don't have any wires or any connection to the ship. They just get the fire control data before launch, and then off they go to go find their submarine. Okay, the SH-60B SEAHAWK Lamps helicopter. They carried 2 of these. Very reliable air design. This is a great helicopter. It has multi-roles. The Spruance used the Lamps 3 version for anti-submarine warfare, but you see these helicopters being used in all branches of American service just because it's such a great helicopter. But this is the ASW version of it. There you can see it has the T700 GE gas turbine engines. It's got the ALQ 1420 ESM with the APS 124 radar. It's got a cargo hook, sonar buoy antenna, because once they drop the sonar buoys, they still have to communicate with them. The Mad Bird and pylon, that's magnetic detection. So they'll string that down a little bit below the helicopter as they're flying along. It's on a cable, and that will detect any magnetic anomalies under the water. And that's likely going to be a submarine. And then they'll go back and drop some sonar buoys on it. And then if they want to, drop a weapon on it. So it's a 2-engine helicopter used for over-the-horizon targeting and ASW warfare. It does have that APS 124 surface search radar, which is data linked back to the ship. So it can extend the ship's surface search to over-the-horizon capability by simply flying a helicopter out there and turning on its radar. So it deploys the sonar buoys, like I said. It can shoot the AGM-119 Bravo Penguin air-to-surface IR missile. That's right, IR. Infrared guided anti-ship missile. It has a surface search radar, and IBM integrated the electronic systems into a data link that is then shared with the ship. So IBM was involved in this project as well. All right, so here's some great pictures of the interior design of these Spruance class ships. They were lauded by the enlisted men and crews that served on them for being engineered with crew habitability in mind. They have very open spaces that are well lit, easy to work in and move around. It's relatively a comfortable ship to be stationed on. So when these came out, sailors were trying to get orders to the Spruance. If they couldn't get on a carrier, get on a Spruance. Here's a picture of the galley and the crew's mess eating spaces. I want you to take a look at the toasters there in the center of your screen. Notice how each toaster has 4 slices, cooking 2 at a time. That's the kind that we had on the submarines, except we just had 1 of those. We didn't have room for 2. Can't be using up space for 2 toasters. Nope. All right, so here's the living spaces there. You can see the berthing quarters, 3 racks. Look at all the room they have above the pillow. The distance between racks is almost twice as much as you have on submarines. I mean, you could sit, it looks like you could sit in your rack and read a book instead of just laying in it. And the ship store there on the left cracks me up. I love how everything in the ship store is a different variety of cigarettes. You went to the ship store to buy everything from, toothpaste to books to candy called Gee Dunk, but also cigarettes back in the day. You can't even smoke on board submarines now. Not even allowed. The times have changed. All right, Combat Information Center. This is the heart and soul of the ship in its warfighting and navigation performances. There you can see some operators looking down at the large circular radar displays there on the left and the right. And you can see the commander or the officer of the deck there in the left. That would be the captain's chair whenever they're at battle stations. But when they're not at battle stations, the senior watch officer would sit up there. And from that one seat, he could see all the sensors, whether it was, navigation radar or the SQS-53 sonar, or if they had the helicopter out there, all the helicopter sensors. He could sit there in the center and see all the information and take it all in at once. With the advent of SQQ-89, though, we give him one display, one very large display, where he can fuse all that data together. That's something that came about in 1985, which was a few years after these ships were built, right? About 10 years after that they were built. And the SQQ-89 is something that we continue to improve today, to give them, one glance full picture of the entire tactical situation around them. The advances made in these systems over the past 30 years is incredible. Let's go back to February 1988, the Black Sea incident. This caused a lot of consternation in the American press. The Ticonderoga class cruiser, the Yorktown, was accompanied by a Spruance class destroyer, USS Charon, and they're sailing in the Black Sea. This is before the collapse of the Soviet Union, so they still had the Soviet Union there, but they were off the coast of Ukraine, and they were right outside international waters. Americans do this a lot. We call it freedom of navigation, because we're inside national waters technically and accurately and legally, but we're also right on the border of another nation, whether it's China or Russia, in this case, Soviet Union. And they don't like that, so in this case, they sent a frigate out to greet us. This frigate, the Brezhneventi, says on the radio that, hey, we're going to ram you if you don't move away. And our radio call back to them was, we're exercising legal navigation in international waters, which was 100% true. And this little Krevac comes out. This Krevac is so much smaller than the Ticonderoga that you see photographed here. He comes up alongside him and is running parallel with the ship, just a few feet apart from each other, showing incredible seamanship, because whenever you get two ships side by side, within, say, 10 or 20 feet of each other, that begins to have a suction effect, wanting to bring the two ships together. And so even with that suction effect, they ran parallel to each other for a few minutes. And the American crew went topside with their little cameras. And there's even video of this on YouTube, some VHS quality video that is kind of hard to make out, but you can see this happen in real time. And the Americans are waving at the Russians, taking pictures, cracking jokes, taking it very lightheartedly, whereas the Russian sailors who did go topside, they're looking kind of glum and not that happy. Some of them do wave, but most of them are just very serious business-like. They're basically, the Americans are acting like this is everyday sailing, because for them it is, and for the Russians, they're a little bit pissed off. And so then the captain orders a hard right rudder that you see here, the Russian captain, and slams his ship bow into the stern of the Ticonderoga there. Now there's no damage to either ship. It just basically trades some paint, international, exchange of ship paint, and that's about it. This could have gone a lot farther. I mean, this could have escalated out of control, but the American captain kept his cool and, reported the incident immediately and continued about his freedom of navigation. They continued on this course for another couple hours, which took them away from the coast of the Ukraine. But this was the Black Sea incident of 1988. Some of the other programs that the Spruance was involved in was the Advanced Enclosed Mast System, so AEMS. This advanced technology demonstration was just a test platform for what would eventually be installed on the San Antonio class transport docks. This test began in 1996. Testing began in 1997, technically, and was finished by 1999 and considered an outstanding success. This was a very successful redesign of the masts of American ships. And there at the top, you can see the old style mast on the Spruance class, and behind it is the new style mast. And what it did was essentially made it more radar transparent. So it reduced the radar cross signature of the ship significantly. So going forward, all ships going forward, we're going to have a mast like this. It was made out of modular panels, so it was easy to maintain. You just pop those panels off, you can get inside and do your maintenance. They could also, if they wanted to, remove the mast and just plug a new one on because they were modular themselves. But to keep that from happening, they also made them individually modular. So like if one part needed to be replaced, they could just pop it off and pop a new one on in port with a crane, because these things are huge. You can't do it with your hands, but that's how it was. And this was put into final production, like I said, on the LPD-17 class. And there you can see they had 2 masts, forward and aft, for them. All right, other operations the Spruance class was involved in was the maritime intercept operations in the Persian Gulf. Basically, they were enforcing UN sanctions against Iraq after Iraq invaded Kuwait. So they were putting basically an embargo, a naval embargo on the country, and they were enforcing it, inspecting shipments as they came along. Eventually, there was a program called Oil for Food. This was after the war, the first war in the Gulf. And so shipments would come in and they would just make sure that it is food. There was a whole process to this where they had to get permission to make the delivery before they even left port. And so there was no surprise shipments. There was, ships expected on this day at this time, and the Navy was ready to inspect them. If the ships arrived without that schedule or did not follow that schedule, they were simply turned away. They didn't even get inspected. They were like, no, you can't deliver it, regardless of what you have on board. So, and this was done for both inbound and outbound ships. Okay, 1990 Desert Shield turned into 1991 Desert Storm. They were used for fleet protection during the Gulf War, but the Spruance had a unique role in participating in the largest amphibious deception in modern naval history, which was when we started the land war in the first Gulf War, 1991, Desert Storm. The Marines faked an amphibious landing on the shoreline of Kuwait. They never actually landed, but in the days leading up to that, they had a lot of radio transmissions and flyovers and acting like they were preparing the beach for an invasion. And this kept the Iraqi army distracted, looking towards the sea, at least in part, while the American army came in from the west and smashed them. I mean, just smashed them. It was a very one-sided victory that did have some hard-fought battles. It was not an easy war for those people in those battles. But part of what made the job for the American army a little bit easier was this amphibious deception, where we faked, essentially, an amphibious invasion that never occurred. In 1994, Operation Uphold Democracy took place in Haiti. This began in 1991 when the army of Haiti overthrew the government because the government was completely corrupt. But turns out the army, once they got in power, they were corrupt too, and they didn't want to give up power. So the UN started imposing sanctions on this already poor country, and it wasn't good for anybody. So in 1994, the U.S. led a multinational force, which included Spruance destroyers, down to Haiti with 20,000 troops in the little troop ships, and conducted an invasion. It was an unopposed invasion of Haiti. They had a strong show of force before the landing, lots of flyovers. It was very clear to everyone in Haiti that there was no point in even resisting, because all you were going to do is get yourself killed, because the Americans were coming in force. And in 1995, the U.S. transferred the peacekeeping operations to the United Nations, who I believe are still there today. Things in Haiti and even the Dominican Republic are not that great right now. All right, self-defense test ship. Sadly, all the Spruances are gone now, so they had to pull one out of mothballs rather than destroy it in 2004. The Paul F. Forrester, now officially known as the Paul F. Forrester, DD-954, became the U.S. Navy's sole self-defense test ship. This ship is specially modified in some very cool ways. It is remotely operated, so it's like driving around your own little remote control boat, except it's a full-size ship. And it tows a target barge behind it that the U.S. Navy shoots missiles and gun runs at. And so they don't have any mishaps and put anybody in danger needlessly. The ship is not even crewed at sea. It is completely remotely operated at sea. It does also have mounts for self-defense weapons like the Sea Whiz and the Sea Sparrow and other experimental weapons that we're using now, like the new laser turret technology we've installed on this ship, and we shoot missiles at the ship now, obviously unmanned, and we let our new turrets defend themselves, which is a very cool and highly secret program that you'll never see video of, but it exists and it's going on right now, and it's really cool. Anyway, so the fate of the class. Oh, the Spruance. For such a well-performing class, she has met a very sad end in that there is not a single museum or place you can see her anymore. For a short time, you could visit her, one of the ships in San Diego, but they're gone now. They're all scrapped, except for the ex-Paul F. Forrester being the target ship. And but all the other ones have been scrapped, and most of them have been sunk and turned into artificial reefs at live fire exercises, as you see here, which is a unfortunate end to a ship that they should have at least made one into a museum, I think. So final thoughts. Well, it was a great ship for ASW warfare. Had very long anti-submarine warfare detection range. The SQS-53 sonar, which is now the SQ-53 Charlie, highly capable, long range anti-submarine sonar. Very impressed with it. And like I said, we continue to use it today. It's so good. The idea, the tactics today, and this kind of began back then, was to just look so far away from the fleet, say 80 to 100 miles, that you can see everything under the water in this 80 to 100 mile envelope. And as long as the Russian submarines or enemy submarines, Chinese submarines can't get in that 100 mile envelope, well, then they can't conduct a torpedo attack. And so an ASW victory in modern warfare is not killing the submarine. It is preventing the submarine from shooting or attacking you. Now, that role is kind of changing in the hypersonic missile age and long-range supersonic missile age. China, for example, has a submarine-launched cruise missile that begins subsonic and has a range of greater than 150 miles outside the range, the unclassified range of this ASW sonar. So it can still perform an attack outside this detection. So it's really the role of the ASW American role anyway, by definition, is changing because the weapons submarines are using to attack fleets are slowly moving from torpedo to supersonic and then eventually hypersonic missiles. Going back to that Chinese missile, it starts out at a cruise subsonic speed, but once it gets within range of its target, it quickly goes to supersonic speed. So it does, a rapid speed change at just a few feet off the water into its terminal execution. Some of the downsides of this ship is it did have relatively weak AA defense, even though it had two Sea Whizzes and had the Sea Sparrow launcher on the back. If you had multiple incoming air missiles from the bow, you just had one Sea Whiz and that forward mounted 5-inch gun to try and defend you. But again, this wasn't an air defense ship, so that's not a very strong criticism because it wasn't its job. It really relied on the fleet itself to defend it from air attack while it protected the fleet from submarines. That's how fleet tactics work in modern naval warfare. But it was a fleet liability during a missile attack. But in the end, even the shape of this ship is iconic from the Cold War age. And it is a ship that cuts a hell of a profile on the horizon. It is interesting to see. And if you can see it through a periscope, you're already too close to it. It'll snap you up if it has a good sonar operator because it has a great sonar system. All right, that's it for the Spruance class subbrief. Thank you everybody for listening. I want to give a special shout out to all of the department heads and division officers that make this possible.